according to lecture. Section 1.6. That's going to take us to page 8 squared. We're on page 8 squared. You have to do math to know what page to be on. 8 squared? Yeah, we're on page 64. And we're going to be covering absolute value equations and inequalities. Absolute value equations and inequalities. All right, here we go. We're going to start with something easy. Number 25. Probably the most basic equation we could start with right there. Absolute value of x equals 3. Now, does anybody know what absolute value does to the number inside? Makes it positive. Absolute value, whatever's inside, always comes out positive. Got it? Not opposite, positive. So what they're asking me here in this example is they're saying, what numbers can I take the absolute value of that will produce 3? 3 is one of the answers.
-3.
And -3. So this equation has 2 solutions, because when you take the absolute value of +3, it's already positive, it comes out positive, okay? But when you take the absolute value of -3, the absolute value makes it positive, and it also comes out to be 3. Do y'all see that?
Yes.
Okay, so an absolute value always produces 2 solutions?
Yeah,
Not always, no, not always. So would y'all like to see when it doesn't produce 2 solutions? Okay, so let's look at 29. Again, another very basic example, not much to it, but it's asking us what numbers can I take the absolute value of that will produce 0? 0 and -0. However, 0 and -0 are the same thing, because you can't have a positive or a -0. And so here the only answer that makes that equation true is 0. Do y'all see that? 0 is the only number that you can take the absolute value of and get 0. Y'all got that?
We've done this lesson.
No. No, we haven't.
That's something similar.
Oh, I actually did cover this the first day in 13-14. Yeah, but it's a topic that overlaps both classes on the student learning outcomes, and so we cover it twice. Okay? So if you don't recognize this, then pay attention. If you do, just sit back and relax, okay? Enjoy the show. One more example, we're going to look at number 28, which is the absolute value of x equals -9. So again, another very basic example. And here it wants to know what numbers can I take the absolute value of that will produce -9. And this one has no solution, because an absolute value always comes out positive, and a positive cannot equal a negative. And so there's a couple of ways to write this. You can say that. What symbols are those? Braces. And remember, braces indicate a set. And what is the set of answers? Well, there's no answer. So we call that the empty set. It's the set of nothing. There's no answer. Or you can say this. And that is the symbol for no solution, okay? Now, do y'all understand that an absolute value equation can have two solutions, one solution, or no solution. And it all depends on whether the number on the other side is positive, 0, or negative. Okay, so now we're going to dive into the actual problems that have some work to them. And since we covered this already once, I'll not drag my feet, okay? Number 36. I'm also going to do different examples than I did previously, just so you have more different examples. And just to make sure I get everybody counted present, is that Juana?
Yes.
And is that Jasmine? Okay. All right, so is this equation going to have one solution, two solutions, or no solution? Two. We know that ahead of time because the absolute value equals a positive number. That's how you get two solutions. And so to find those, we're going to say 9y minus 2 can be 17, or 9y minus 2 can be negative 17. Because both 17 and negative 17, when you take the absolute value, will produce 17. And so we're going to have to solve both of those, okay? Moving the minus 2 over, that's going to give me a 19. And divide both sides by 9. Does 19 over 9 divide nicely? And so let's leave it improper. That's the way I like it. Proper. And is that Kenneth? Huh? I got the wrong one. That's Jalen. Now for the other solution, negative 2 comes over, makes it a positive 2. Negative 17 plus 2 is negative 15, and divide both sides by 9. Does negative 15 divide by 9 nicely? Oh, but can it reduce?
Yes.
Got to reduce it. And do you see if a fraction can reduce, you need to reduce it to lowest terms. If you don't, it'll cost you. How's that? So far, so good? Yeah. Okay. Next, let's jump down to number 52. And the instructions say solve. We're going to have to solve for x. And this is the first problem that we come to where the absolute value is not isolated. And I don't know if you remember or not when we covered it before, but you have to have the absolute value isolated to solve it. So who needs to get rid of first, the 11 or the 2? The 11 has to go first. And the reason is because we're trying to solve for x, right? So all of this is one term, and the 11 is a separate term. You have to isolate the term that has the x first. That means that any other term that doesn't have an x, you got to get rid of it first, okay?
Incoming message.
Is it called PEMDAS or something like that?
Yes, order of operations. Say it again.
It doesn't apply in this case?
It sure does. When you're solving an equation, it goes backwards. So you have to get rid of addition, subtraction first, and then you can get rid of multiplication, division. Yeah, it kind of works backwards, okay? So the 11 moves over, makes it negative 11. 25 minus 11? And do you see now I can get rid of the coefficient of the absolute value? That 2 is being multiplied. So how do I get rid of it? Divide. Now we divide by 2. And I want to point out something I've seen people do and warn you not to do it, okay? I've seen people, instead of dividing by 2, they'll distribute the 2. That's bad, okay? Because the absolute value is not like parentheses in that you can distribute into it, okay? You have to get rid of that 2 by dividing by 2. And now we have the absolute value isolated. And now you can determine whether there's going to be one solution, two solutions, or no solution. And we know it's 2 because the 7 is a positive number. And now we split it in 2. 2x minus 7 equal to 7. And we know that 2x minus 7 equals negative 7. So you have to set it up now with 2 equations and solve both of them. Most common mistake on a test, people will forget that you have to do the negative 7 part, and they'll only do the one solution, okay? Do y'all like me warning you about what people commonly screw up on, and then you can make a note not to do that?
Yeah, because I was going to multiply.
Yeah. So don't distribute, and then don't forget to split it in 2, okay? If it's absolute value, you got to split it in 2. All right, here we go. Solving for x. Bringing the negative 7 over is going to give me 14. And divide by 2 is going to kick that back down to a 7. On the other one, bringing the negative 7 over is going to make that a 0. And dividing by 2 is going to give me 0. And so again, we get 2 solutions. Everybody see how that works? You're going to have to know how to work it, okay?
So PEMDAS, it works backwards on every equation?
When you're solving an equation. But that's just to give you an extra instruction there on maybe how to think about it. What you really need to do when you're solving an equation is understand what needs to happen rather than just thinking about order of operations. You need to know the letter we're solving for. That term has to be isolated first. And then if that letter has a coefficient, then you can get rid of it, okay? So we had to get rid of the 11 because we have to isolate the term that has an x. And then once we isolate that term, then we can start peel. It's like an onion. We can start peeling off the layers until we get down to the center. Y'all understand that? It's almost like well, it's a lot like an onion, okay? Or filleting somebody. You got to strip off the layers, okay, until you get down to the bones. I'm sorry. It's a bad
Incoming message.
negative example. And I'm so sorry my phone's going crazy. There we go. All right, let's try another example. Number 58. 58. And if I'm not mistaken, this may be the type of equation that most people struggled with, where you actually have the two absolute values, and how do you deal with that? So, like all the other examples we've done so far, where the absolute value equals a positive number, we know that's going to split in 2, right? And can y'all see that this is also that case, because this is an absolute value, but this is always going to be positive because it's absolute value as well. And so a positive equals a positive means we're going to split it in 2. So the first time you split it, you're going to leave it exactly the same. The first time you copy it down, you just drop the absolute value symbols. Everything stays the same. The second time you copy it down, just like on our other examples, like where we said the 7 stays a 7, and then the 7 becomes negative. Okay, so now the x plus 3 is going to become negative. The x plus 3 is going to become negative. You make the whole freaking thing negative, okay? Now, why did I put it in parentheses? Yeah, so I won't forget to distribute, because that whole thing has to be negative, which means the negative applies to every term. And then I can distribute the negative, okay? So we're going to have 2x minus 8 equals negative x minus 3. And we're going to have 2x minus 8 equals x plus 3. Y'all see that? We now have the two equations. All right, so let's solve the left one first. Are we ready? Okay, so who needs to move over? The negative 8. And who else? The x. Now, do you understand why those two pieces move?
You have to get the x. You have to get the
To
x
get them
together
by.
Okay, I hear a lot of stuff, and if I put it all together, it's correct. Yeah. Because we want to get our like terms together so we can combine like terms. Got it? So all of the x's want to get together so they can make x babies. And then the constants want to get together. Never mind. So that's going to be 2x minus x. That's going to be 8 plus 3. Don't forget, when you move it, you got to change it. And then that's going to give me x equals 11, and I'm done with the first one. Now, on the other equation, who needs to move? Same. The negative, but this time it's negative x, and it sure will. It'll turn into a positive. And that negative 8 turns into a positive also. Now, let's see LT. Oh, yeah, boy. Here we go. 2x plus x. 8 minus 3. Divide both sides by 3. Oh, that's improper. But that's the way I like it. Man, can y'all tell how much fun I have teaching?
Yes.
I really enjoy what I do. I hope y'all enjoy the show.
Yes.
Anybody have any questions about that? Is there any way to check those answers? Yeah, like the lady on the Glade commercial said, right? Plug it in, plug it in. You got to plug it in. Do we need to do any more absolute value equations? Are there any harder than that? Unless you think that fractions are harder, they don't get harder, okay? I can throw in some fractions if you think that's harder. Probably not, no.
Can we do it on our own now?
Oh, would you like me to give you one and see if you can do it? Yeah, sure. Do you want another one with dual absolute values, or do you want one more like the previous one?
Choose for us.
Huh?
But let us know which one is.
Okay. Let me see here. Oh, okay. I got one. Are you ready? Number 69. My favorite. And Lexi, you said you want a couple of minutes to see if you can do it? You got it. 2 minutes on the clock. On your mark, get set, go. All right, y'all about ready to look at it? That's been about 2 minutes. All right, here we go. Taking a look at it. We've got, my pen went away. 1/2 x minus 5 equals 1/4 x plus 3. Remember I said you copy it down one time? Stays exactly the same. And then if I go ahead and try to solve that, do you notice I've got an equation with fractions involved? So I would really like to eliminate the fractions at the beginning. Is that okay? Okay. So what I need to do is I need to multiply both sides by the common denominator. And what would be the common denominator of 1/2 and 1/4? I guess again? 4. You see, if I only multiply by 2, it's not going to get rid of the 1/4. So I have to multiply by the common denominator of all the fractions in order to get rid of the fractions. And so we're going to distribute the 4 here. What is 1/2 of 4? 2. That's going to give me 2x. And then 4 times -5? -20. And then the 4 is going to distribute on the other side. What is 1/4 of 4? 1. And 4 times 3 is 12. Now, do y'all see what I just did? And was it legal? Whatever I do to one side? And I multiplied both sides by 4. I did the distributive property. And if you need to check my multiplication with your calculator, with your fancy fraction button, you can do that.
You can always do that with the fractions.
Always. If you have fractions involved, you just multiply both sides by the common denominator. It'll wipe them out. And now what I'm going to do is the double switcheroo. I'm going to move the -20 in the x. That's going to give me 2x minus x, 20 plus 12.
So when you work it out with the fractions in there, you still get the same answer.
Oh, yes.
Yeah.
Yes. You can also work with the fractions and you should get the same answer. I just don't like working with fractions. Yay. All right. So is that the answer?
Yes, no. Let's wonder to the other side.
Good. Okay. So that's what I meant is that the only answer? We still need the other side, right? All right. So here we go. 1/2 x minus 5. Remember the first one doesn't change, but the second one is negative 1/4 x plus 3. And so that negative is going to need to distribute. 1/2 x minus 5, negative 1/4 x minus 3. And now I still have the same problem of having fractions involved. Is the common denominator the same?
Yes.
Yes. So I don't have to figure that out again. I'm just going to multiply both sides by 4. And I don't know if you realize this or not, but it's going to give me the exact same terms as before. So that's going to give me a 2x minus 20. On the other side, now that's negative x minus 12. And y'all know you can stop me and ask at any time, right? Y'all know how that works? Slow your row, O'Neill. Got a question.
Why would you have to do all that again when you can just take that equation and negative?
That's a good point. Why would I have to do all of this again when I can just take this equation and make those negative? You can't. Yeah, you can bypass that. Good point, Lexi. Now,
You don't require that working equation.
it would be nice. And the reason I'm doing it all over again is because I have to, use my good math etiquette and show really how it works, okay? Y'all don't want me skipping too many steps, right? Okay. Here we go. So we're going to get 2x plus x. What? Why did I write 3? Man. And we're going to get 20 minus 12. 20 minus 12? And then 3 doesn't go into 8 evenly. So we're going to leave it effed up. We're going to leave it fractioned up.
So how do we check on our calculator? Because if I did it with the fractions, then I get 2 over 0.75.
2 over 0.75. So on your calculator, you have a nice one. Hit the fraction button. You know what I mean? The box over box.
Oh, that's right. Yeah.
And then put 2 over 0.75. And does it verify?
Yep.
There you go. With a nice calculator, you can easily verify those. Anybody else have questions on that? Okay, I absolutely must get on to the next thing, okay? So I'm going to switch pages since it's kind of different than what we've been doing. Going to a new page. And we're going to start with problem number 75. And we're going to talk about absolute value inequalities. Y'all see the difference? It's got a less than symbol. And so you're going to have to know, well, how do I work when it's an inequality, okay? Well, it turns out it's pretty much like the other ones. If this statement is true, then you're going to split it in two, like we've been doing, okay? So is there positive stuff that is less than 1?
Yes.
Yeah. There's some positive stuff less than 1, right? What about a half? A half is less than 1 and it's positive. What about a fourth? A sixth? A tenth? Y'all see what I'm saying? There's a lot of positive stuff less than 1. This is true. And so we're going to split it in 2. And just like on the other problems, the first time you split it, everything stays exactly the same. Y'all see that? Everything identical. But the second time you split it, the 1 is going to have to be negative. And guess what happens to the inequality?
Why?
Because. Yes. Yes. I'm sorry, I don't like to use that
No,
very
you
often.
can do that. That's totally acceptable.
Yes, because, yeah, like at home, because I said so.
That
Yeah.
works.
It's because that's what you have to do to make it work. Yes. Okay. And there's other reasons why. Maybe we could write a term paper on why it flipped. Okay, maybe not. So do y'all understand the first time you copy it, everything stays the same? The second time down, change the arrow and the sign, right? The inequality and the sign. And now we're going to solve for x. So on the first statement, if I move the negative 1 over, that's going to make it positive. And 1 plus 1 is 2. On the second statement, I move the negative 1 over. That makes it positive.
0.
That's going to make 0, okay? Now, I don't know if you noticed, but I now have 2 inequalities. And I think we did talk about inequalities in here one day. And do y'all remember I said if there's 2 of them, that's called a compound inequality. Y'all remember that? If there's 2 of them, it's a compound. Now, normally when we did those, there was a word in the middle. What were the 2 words that we saw? And you're going to have to get the word right here. You're going to have to pick and or, but you have to pick the right one. Are y'all ready? Okay, this one is and. A good question.
It's not greater tree.
Say that again.
Is it because it's not the greater than equal
The equal to has nothing to do with it, but the greater than does. So what is this symbol? Less than. If your inequality has a less than, it's an and.
But it has greater than, then it's an or.
There you go. If it has greater than, it would be an or. Now do y'all see how to tell which word to use? Less than, greater than,
Or.
and the equal to part doesn't matter. Okay, now let's go to the number line. I've got two critical points. Which one is my leftmost? Leftmost. 0. And does it matter if you get those in the wrong order? Oh yeah, yeah, big time. Are those going to be open circles or solid dots? Open. And which way am I going to shade? So from the 2, we're going to shade to the left. But from the 0, we're going to shade to the right. Remember I said if the letter is on the left, you shade the way the arrow points. And so this indicates that we're going to shade in the middle. Got it? Great, right here. Greater than 0, but less than 2. That's going to give me shading in the middle. And now from that graph, I can write the interval notation. Parentheses. There you go. And that is interval notation. And that's what we're going to need to produce for those. For these absolute value inequalities, the ultimate goal, I think, is interval notation. Now, sometimes they will also require the graph, so you'll need to provide the graph. And very, very seldom will they ask for set notation. Okay? More often than not, it's interval notation. Y'all want to try another one?
Yeah.
All right, number 77. And what is the first step I'm going to have to do? Yes, because you have to isolate the absolute value. We're going to have to get rid of that 5 first. Man, I don't think I can stress that enough. I don't care if it's an equation or an inequality. If it's got an absolute value, you have to isolate it first. Y'all got that? And then if it's true, split it in 2. Is there positive stuff less than or equal to 2? Yes. There's a lot of positive stuff less than or equal to 2. That is true, so we're going to split it in 2. X plus 4 less than or equal to 2. Is this going to be an and or an or?
Or.
Oh, wait, why?
Oh, no, it's
I thought you said if it was okay.
Less than. Oh, and remember your left hand.
It's less than.
Less than, right? Left hand?
Less than.
Okay, fine. And then we got x plus 4 is?
Greater than or equal to -2.
There you go. Greater than or equal to -2. And now we're going to solve both of them. Moving the plus 4 over makes it a -4. 2 minus 4, -2. And remember that also means intersect. Moving the plus 4 over makes it a -4, makes a -6. If I combine like terms. And then to the number line. What is my leftmost critical point? -6. Everybody agree -6 is smaller than -2? Open or solid?
Solid.
And which way will I shade? So -2 to the left, -6 to the right. Do y'all see that indicates shade in the middle? And now I can get the interval notation. Bracket. And everybody knows the difference between when to use a parenthesis and a bracket, whether it's an open circle or a solid dot. Got it? Okay. Open circle, parenthesis. If we use an open circle, why do we use an open circle?
It's pretty.
No, because there's no equal to part.
Oh, okay.
And these have the equal.
So the equal part is what drives the solid. Okay.
Yes.
Thank you.
The equal part is what drives the solid. And the solid is what drives the bracket. All right, so I got another one, number 81. And I've got about 12 minutes left. 81. Is the absolute value isolated?
Yes.
It is. There's nothing outside of it, is there? It's only absolute value stuff on one side. And is it true? Is positive stuff greater than 10? There's a lot of positive stuff greater than 10, right? That is true, so we're going to split it in two. 2y minus 7 greater than 10. Is this going to be an and or an or? Ah, this is an or. Everybody see why it's an or? Because this time it's greater than. 2y minus 7 is also less than -10. Everybody okay with that? Questions? All right, here we go. Let's solve each one. -7 moves over. Makes 17. Divide both sides by 2. 17 divided by 2? It's improper. And you could leave it, but I'd like a decimal this time. Now, do you understand why you might want a decimal sometimes? What if I was given a number line that's already numbered? Would it be easier to find 8.5 on the number line, or would it be easier to find 17 halves?
How do you make your calculator change that out?
SD. Got it? The SD button is how you make a fraction into a decimal. Y'all might want to learn that button. It comes in handy. Next one, -7 comes over. That's going to be -10 plus 7, which I think is -3. Divide both sides by 2. Y is less than, and we're going to go with the decimal again, okay? Any questions? Okay, on the number line, I've got -1.5, positive 8.5. Open or solid? Open or solid? Open.
I thought you said there was an equal sign.
It's solid.
Oh, I wrote it down wrong.
If you've got the equal to part, it's solid.
Oh, actually, I did write it down right, I just didn't read it.
Okay. And this time, which way are we going to shade? Yeah, 8.5 to the right, negative 1.5 to the left. Now, do y'all see the difference in shading with and versus or? Did y'all notice that if it's and, it always shades in the middle? If it's or, it's always going to shade opposite. It's always going to shade on the outsides, okay? And so now I'm going to need you to provide me with the interval notation.
Negative infinity. Positive infinity.
1.5.
Oh,
8.5.
Wait, what is the, huh? What? Parentheses.
And then another parentheses. 8.5 to 50.
And there's one little piece missing.
The U for union.
The U for union. Because when there's two separate intervals that are solution, remember the U is the glue that sticks the two pieces together, okay? Or means union. And does everybody understand why, especially Luis, why it's not positive infinity here? Because if you're doing interval notation, it has to go from left to right. So if the shading abruptly stops, then you have to say, hey, it stops there and then picks up later and keeps going. Do y'all understand what I'm saying? That the interval notation should describe what is shaded from left to right. From left to right. All right, how are we doing on time? Okay, I got 6 minutes. Let's talk briefly about some of the special cases. So these are going to be my examples. Okay, let's look at that problem.
That would not be true.
So can there be positive stuff? Remember, this is positive, less than negative 3. There's no positive stuff less than negative 3? I think everything that's less than negative 3 is going to be negative, right? Yeah, so this is no solution. You don't even do any work, okay? Positive stuff cannot be less than negative 3. That's a definite no solution. Okay, what about this one? My second example. Okay, so if I replace this with 0, is 0 less than 0?
Equal to.
Right? So it would have to have the equal to be a solution, but it doesn't have the equal to. So this one is also no solution. Again, because there's nothing positive that is less than 0. Okay? And then we're going to deal with what Lexi brought up, that if we have this less than or equal to 0, then there is a solution, but there is only one solution. What is the only way that this can be less than or equal to 0? It's if it is equal to 0, because everything less than is going to be negative, right? Anything less than 0 is negative. So the only thing that's going to work here is if that is equal to 0. And so you would need to set that equal to 0 and solve. So there are some trick questions here that you really have to pay attention to get the right answer.
So you can just drop the less than sign when you pull it out.
Right. And that's because the less than doesn't apply because everything less than 0 is negative and cannot be part of the answer. Okay? Now, I got another one. 3x minus 4 greater than negative 2. Okay, so is that true? Is positive stuff greater than negative 2? Okay, but think about it. Is every positive thing greater than negative 2?
Yes.
Do we need to draw a number line? If I look at negative 2 on a number line, and then we've got negative 1, 0. Y'all see? Look, here's negative 2. And then everything from here over is... So isn't every positive number greater than negative 2? So this is a problem that I don't have to spend any time working on. Because the answer is all real numbers. Okay, let me help you, okay? I see some people struggling with this mentally. Watch this. Any number that I plug in for x, I don't care what number, any number that I plug in for x is going to work out and give me something that is positive. Any number that I plug in for x is, I don't care what this number is, when I take the absolute value, it becomes, which is always going to be greater than negative 2. So that verifies that this is all real numbers because I can throw anything in for x and it's going to give me a true statement.
And why did you do the negative infinity?
Because negative infinity means any negative number will work also. Okay, pick me a negative number.
Well, not any negative.
Yes, any negative number.
Negative 7.
What is 3 times negative 7?
Negative 21.
What is negative 21 minus 4?
Negative 8, 17.
No. Negative 21 minus 4 is negative 25. Because two negatives, when you combine them, makes a bigger negative. Oh, but then what does the absolute value do?
Negative positive.
Which makes it a positive, and then it's greater than negative 2, okay? So any negative number that you plug in here, even if this works out to be negative, the absolute value makes it, and then it becomes a true statement, okay? You know what? We need something like that for getting into heaven. Right? No, never mind. I better turn the recording off before I...